In this lesson, we're going to look at how to factor 4 different types of quadratics. And these quadratics will have this form up here. So not all quadratics can be factored. Sometimes when you're plotting out a quadratic, you may have a situation where the curve does not cross the x-axis. In this case, we have no real values for x in this quadratic. In other words, we have complex roots. We can have a situation where when we plot out our quadratic equation, it does in fact cross the x-axis here, but the locations where it crosses the x-axis are not rational numbers. In other words, they cannot be represented as a fraction, for example, r1 over r2, or as a whole number, for example, 2, 3, 4, etc. So in the situation where our values of x are irrational, in other words, we have a number that goes on forever, we need to use something called the quadratic formula to solve our quadratic equation. And the quadratic formula looks like this, where our values of x are equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now you can use the quadratic formula to work out quadratic equations that have a rational solution, like this here, but you can also factor these types of polynomials to arrive at these x values here. So we're not going to use the quadratic formula today, but we do need to establish whether our quadratic equation first has real solutions, like this over here, and also whether these real solutions are rational. So how do we do this? Well, let's start with our first quadratic, which is 8x squared plus 12x plus 4. Now, to see whether we can factor this, we need to find the discriminant using this equation here. So d is equal to b squared minus 4ac. Now, if this quadratic equation produces complex solutions like this, where the curve doesn't cross the x-axis, then our value of d will be less than 0. For our quadratic above, we've got b squared, which is 12 squared up here, minus 4 times 8 times c, which is 4. And this value is equal to 16. So we know that this quadratic here has real solutions. Now the next thing we need to do is to see whether our x values will produce rational numbers. And we determine this by seeing whether the root of this value is a whole number, or whether this is a perfect square. So since the square root of 16 is 4, we know that this quadratic has rational values for x, and we don't need to use the quadratic formula or quadratic equation. So we've established that the discriminant is above 0, so it has real solutions, and it's a perfect square, meaning that our values of x when the curve crosses the x-axis are rational. They're not irrational numbers. So we can go ahead and try and factor this quadratic. So our first step is to list all the factors of a multiplied by c, which in our case is equal to 8 times 4, which is equal to 32. So we need to find all the factors of positive 32. So the factors of positive 32 are, and you'll notice here that I've also multiplied the negatives together because they also sum to positive 32. So what we have to do with these factors now is see which two factors out of all of these 6 options here sum to positive 12. So what two factors here can we add together that will give us a positive 12? So we can't add the negative numbers together because we'll get a negative number as a result. But with the positive numbers, we can add 4 and 8 together. So 4 plus 8 is equal to 12. So these two factors can be used in the next part of our process here. So we can rewrite our quadratic above as 8x squared plus 4x plus 8x plus 4. And you can see that 4x and 8x is equal to 12x. So if we separate our quadratic now into two parts, by putting brackets around the first two terms and the last two terms, we can find the highest common factor out of these terms in the brackets here to simplify our quadratic. So first, I'm going to look at the highest common factor between 8 and 4. In other words, I'm looking for the largest value that can divide both 4 and 8 without leaving a remainder. So we can divide 4 into 4 once, and we can divide 4 into 8 twice. So our highest common factor here is 4. So if we place 4 outside of the bracket at the moment, we've got 2 4s go into 8, so we place 2 there, and 1 4 goes into 4, so we place 1 there. Now with the x terms, we do the same thing. So we see what the highest value, we try and determine the highest value that can divide into x and into x squared without leaving a remainder. So in this case, we've got a value of x that can divide into itself and into x squared. So we put x on the outside of the bracket, and because we've got an x squared inside of the bracket, we put x there, and we leave this as 1 because we got the highest common factor outside of the bracket. So we can do the same with the second bracket now. We can find the highest common factor of 4 and 8, which is 4. And because effectively this 4 is multiplied by x to the power of 0, our highest common factor in the x terms is x to the power of 0, which is equal to 1. So we've got 4 times 1 outside of the bracket, which is equal to 2x plus 1. So now if we factor out the highest common factor out of this expression, we get 4x plus 4 multiplied by 2x plus 1. And that's our result. So we can test out our result now by multiplying out the brackets here. So we've got 4x times 2x, which is 8x squared, plus 4 times 2x, which is 8x, plus 1 times 4x, which is 4x, plus 1 times 4, which is 4. And that's equal to 8x squared plus 12x plus 4, which is our original quadratic up here. So we're going to use the exact same process again for the second quadratic equation, which is 6x squared plus 5x minus 4. And again, we need to see whether the discriminant is a perfect square. So d is equal to b squared, so 5 squared, minus 4a, which is 6, c, which is minus 4. And we need to see whether the square root of this sum here is equal to a whole number. So what do we get? This sum here is equal to 121. And when we square root that, we get a value of 11. So we know that this is a positive number, so the solutions are real, and it's a perfect square, so the solutions are rational. So the coefficient a multiplied by the coefficient c is a dot c, which is equal to 6 times minus 4, which is equal to minus 24. And we need to list out all the factors of minus 24. So we have 1 times minus 24, and out of this list of factors we need to find two values that sum to give a positive 5. So what two factors out of this list here sum to give positive 5? Minus 3 plus 8 is equal to positive 5. So we're going to use these two factors in the next part of our process. 6x squared minus 3x plus 8x minus 4. And we're going to group this again into two brackets and find the highest common factor for the coefficients and for the x terms. So out of 6 and 3, the highest common factor is 3. And out of the x terms, the highest common factor is x. So we move the highest common factors outside of the bracket, and we ensure that the terms inside the bracket multiply to give this result up here. So we're going to do the same with the second bracket. So highest common factor of 4 and 8 is 4. And for the x terms, the highest common factor is 1. So if we factor out the highest common factors now, we have 3x plus 4 and 2x minus 1. And again, we can test this out by multiplying out the brackets. So 3x times 2x is 6x squared. 4 times 2x is 8x. Minus 1 times 3x, which is minus 3x, minus 4. And that is equal to 6x squared plus 5x minus 4, which is our original quadratic up here. So this is the correct solution.